So hello children, in this part 3A of our video lesson we are going to do polar covalent bond. So in the first video you have seen we have done electrovalent bond, 3 types of electrovalent bond. In the second video I showed you non-polar because there was no polarity. Now before going to the polar covalent bond, we should first see what is actually this word pole, polar, or polarity means. See, pole means, if you have seen a magnet, children, if you have seen a magnet in class 9, if you remember, so magnet has 2 poles, north and south pole. So it's a dipole. So two polarity, and they are generally opposite. So this is an electrical pole, minus charge and plus charge. So pole means just the opposite. Earth we have 2 poles, north pole and south pole. So polarity, the word polar means it develops, polarity means opposite charges. Okay, charges. And north and south, you have seen another thing you may have seen, if you cut a magnet, then here south will develop, north will develop. So magnet is never unipolar. So generally here also we have 2 types of charges, negative and positive. So in the first one, there is one concept which will come from chapter 1 called electronegativity, which is a very important concept. So first what I have I'll explain, then again I'll rub it out, and again one by one I'll explain. This simply I had drawn for the children, so I'm starting with this ready-made, but generally I don't believe in ready-made. I'll explain to you in this short video 3 type of polar covalent bonds. So number 1, I told you what is polarity. Polarity means when a molecule develops positive and negative charges. So as compared to part 2 video where we saw non-polar, hydrogen, so they are one thing, their electronegativity is same. So shared pair is in the middle. I'll explain when I do this. I'll explain this back also. Which bond? Chlorine bond, hydrogen molecule, okay, oxygen. Okay, so all this we will just see why they are called non-polar and why these are called polar. Now next thing is, here we are going to take 3 things: ammonia molecule, hydrogen chloride and water molecule. And in my 3 part B video we will see from water we will go to hydronium ion and hydroxyl ion. From ammonia we will go to ammonium ion and H4 positive. Here H3O positive and OH negative. And our syllabus explains that we should show some polar covalent bond like hydrogen chloride. Okay, so this also I'll explain. So here we go. If you see nitrogen, I told you in the beginning that you must always write electronic configuration. So nitrogen is 2,5. So here we have C cross represents nitrogen. So plus 3 hydrogen. These 2 electron will remain, which is called lone pair. So it bonds with 1 hydrogen. I'll explain again. So this is called lone pair. There is 1 lone pair. Others are shared pair. You will say, what is opposite of lone pair? Shared means one, this dot is given by hydrogen, cross is given by nitrogen. So this is how we get ammonia molecule. And this is a polar molecule. You will see, children, delta plus and delta minus. Delta means very small, plus means very small positive charge, and delta minus means very small negative charge, very small. Okay, so now, so this is about ammonia molecule. So what we will see, just I'll explain. Nitrogen, because it has a electronegativity of 3 as compared to hydrogen, which is 2.1, it attracts the shared pair towards itself. So just wait, this I'll explain a little bit later. What is the shared pair, especially with reference to hydrogen chloride, I'll explain. Sometime I see that this concept is not nicely explained in many books also. Okay, so hydrogen chloride I'll explain. So see here, hydrogen has 1 and chlorine has 7. So the 1 pair of electron is shared. So we get HCl. Here we see the electronegativity of hydrogen is 2.1 and chlorine is 3. Okay, chlorine is 3. So what happens? Chlorine atom attracts the shared pair. This is the shared pair towards itself. It has more electronegativity. So just I'll explain this to you again when I do. So remember, the shared pair goes towards itself. So I'll explain to you the concept of electronegativity over here also. Okay, which was there in chapter 1, periodic properties. So here we will learn more nicely what is electronegativity. So here electronegativity of chlorine is 3 and hydrogen is 2.1. So the shared pair shifts more towards chlorine. So therefore this chlorine atom develops a small negative charge and hydrogen develops a positive charge. So this becomes a polar molecule. So two polarity develops, like I told you, plus and minus, or minus and plus, whatever you can take. So this is an example of polar covalent. This is ammonia is also polar covalent. Water is also polar covalent. Water, if you see children, oxygen has 6, hydrogen has 1. You have to write and practice, children. So there is, if you see, 2 shared pairs are there, hydrogen with oxygen, and there are 2 lone pair, children. See here, there are 2 lone pair in this particular. So we will see also what is lone pair effect, okay, when we do next topic. So 2 lone pairs are there. So we get water with, this is water molecule with 2 lone pair, 1 pair of electron here and 1 pair of electron over here. I have shown by cross, H2O. And this is also a polar molecule because oxygen, if you see, one which has more electronegative tries to attract the shared pair. See, this is the shared pair. This is the shared pair. It attracts towards itself. So oxygen becomes negative and hydrogen becomes little positive. So this is also an example of polar covalent. Ammonia is also there and hydrogen chloride. So simply copy, then I will explain to you each one in detail in the second part of the video. And part 3b we will see what is coordinate bond. I told you, where from water you should know the water properly, will move on to hydronium and hydroxyl ion, and from ammonia we will go to NH4 positive ion, ammonium ion. And then in the last video we will see properties, comparative characteristic and properties of electrovalent and covalent bonds. So kindly pause the video and copy, then I'll explain to you this whole thing in detail. So children, first I'll explain to you the hydrogen chloride molecule. Let us see. Hydrogen chloride molecule. Now listen, there is sometime we call HCl as hydrochloric acid also. We have HCl gas also, hydrogen chloride, and we have hydrochloric acid. So when hydrogen chloride gas dissolves in water, we get hydrochloric acid. Okay, so HCl generally you will see we call it hydrochloric acid, but we are talking about hydrogen chloride gas. So hydrogen chloride molecule CRH has, see, I am explaining to you, and here I will also explain to you the concept of electronegativity. So children, pay attention. This is a quite hard concept over here, because periodic table children, they understand ionization potential and electron affinity, but they fail to understand what is electronegativity. So here I am going to teach you electronegativity also. So here it combines with chlorine. Chlorine has 7 children. Okay. So here there will be pairing, you will see. I don't draw an arrow because that will show transfer. So hydrogen has 1 electron, and chlorine, if you see, has 2 7. So generally we take the last one bit. Now what happens, children? H and Cl, 1 shared pair of electron, they share and we get HCl molecule. Okay, this is about the HCl molecule. But now next part, listen all of you. This HCl, this bond, generally you see, this we show through a bond, single covalent bond. Now listen here, HCl, this bond I am showing you longer, it has a shared pair. Now listen, this is a shared pair, remember it is an electron, and chlorine and hydrogen. Okay, so chlorine, if you see, so electronegativity, what is electronegativity, children? Electronegativity is, listen, It is tendency of an atom. Listen carefully. It's tendency of an atom. There are two atoms over here, hydrogen and chlorine, to attract the shared pair towards itself. Okay. So shared pair. Chlorine has three. If you have seen tug of war, children, okay, where the rope is there in the sports time or sports day, two side teams are there, yellow house, red house and all. They are pulling, the red flag is there, okay. So you have a flag here and there is a mark here, okay, within this, okay, who will pull the flag down. So two side teams are same way here. Chlorine attracts the shared pair with 3. So this is Linus-Pauling scale. He gave in 1932. I think there are various scales. So you study Linus-Pauling scale, according to which chlorine has 3. So suppose there are 3 people here and hydrogen has 2.1, 2 people here roughly. This has 2.1, 3. So both attract the shared pair. You will say why they are attracting electrons. So you can understand in simple way that it has more positive charge in the nucleus. There are many factors. More positive charge, and this has less. It has only 1 proton. This has chlorine, if you see, 287, 17 proton in the nucleus. So many other factors are there. So the nucleus has more charge. In a simple way you can try to understand. Okay. So this has more proton in the nucleus, this has less. So this tries to attract electron, which is negative charge. Okay. It has more proton in the nucleus. It has less. There are other factors also. So this shared pair is attracted more towards chlorine. So it develops a small negative charge because electrons are negative, and it develops a small positive charge. Once more, listen very carefully. This is hydrogen chloride molecule where 1 pair of electron is shared. But generally, as we have seen in hydrogen, okay, or your chlorine, since they have same electronegativity, the shared pair of electron was in the middle. Because hydrogen, 2.1, 2.1, two teams are equally applying force. So the red flag will be in the middle. Nobody will win. Here chlorine, same equal power 3, 3. So since we have two atoms which have different electronegativity. Again, once more, what is electronegativity? Tendency of atom. You can see the definition of electronegativity in chapter 1, periodic table. Tendency of an atom in an element, 2 atoms, to pull the shared pair towards itself. It has more tendency. So suppose there are 3 people, 2 people here. Here there are 3 people. Okay, and we imagine here children, they have equal power. Suppose 2 people are more strong, so they may win. But here we take. So they are pulling this shared pair, so it will go more towards chlorine since it is electron shared pair of electrons. So it's negative charge, so chlorine develops a delta negative charge, and this is delta positive charge. So this is what is the value of electronegativity in Linus-Pauling scale given in 1932. So see here, this has 3, this has 2.1. So this is all about our, so remember this polarity develops negative charge and positive charge, and there is attraction between this negative and positive charge. Okay, so this is your attraction. Basically when we have sodium chloride molecule, children, Na positive and Cl negative. Okay, there we saw an electrovalent bonding, negative and positive charges attract. Here also you will see hydrogen bonding in water where there is attraction between one negative charge and the other positive charge. So this was all about hydrogen chloride, children. So kindly pause the video and copy, then very fast I'll explain to you ammonia and water molecule. Next I'll explain it to you what I have explained. Number 1 there is, number 2 here is ammonia molecule. This is NH3, children. So see how I draw. Nitrogen, see here, first we write EC, nitrogen is 2, 5 and hydrogen is 1. Electronic configuration. So nitrogen, children, 1. See here I do cross 3, 4, 5. Here 1 hydrogen will come. See the placing of, children, electron. Okay, how they pair. This 2 will come here, this will come here. Okay, so this is a very nice way of learning and understanding. So nitrogen has 5 electrons. So it shares 1 electron with 3 electron with hydrogen. 1 here, 1 here. So you have to draw. See, you cannot see maths and chemistry and physics. And most important here, this is what we call lone pair. Okay, this we will see next when I teach you ammonium ion. So lone pair effect we will see there. Now, so this is an, see how I draw H. These 3 are shared pair, 1 dot 1 cross, and we have here this lone pair. This is called lone pair. One child was saying alone. If something is alone, how it will be pair? Alone means 1. Alone pair. So pair means 1, 2. So this is lone pair. This is what we were talking about. Ammonia. Once more, nitrogen has 5. 3, see how I arrange, 2 are this side, it combines with 3 hydrogen. Don't draw circle, as I have told you. We generally avoid an electron dot diagram. So this is sharing, and 1 pair of shared electron is shown by single covalent bond. Now coming to the real diagram, so this is more electronegativity, 3. So like chlorine, so it attracts the shared pair more towards itself. So if you see here children, diagram H, H, H. So since this is more negative, this will be slightly positive. So this is also another example of polar covalent. Means white is covalent, it is sharing. But this polarity develops, charges develops opposite, because difference in electronegativity between nitrogen and hydrogen. So suppose 3 people and 2 people, one example I told you. So this is how we draw polar ammonia molecule. And then we move on to the last one before we end this part 3 of the video. Part 3b, we will see coordinate bond, where we will see ammonium ion and hydronium and hydroxyl ion. So here we do water molecule. So once more, see here children, water molecule, how we do? We take oxygen. Oxygen children, H2O, oxygen is 2, 6, hydrogen is 1. So what we do children, oxygen is 1, 2, 3, 4, 5, 6. Here see hydrogen, here I do. This will be pairing, and here there is hydrogen. So you can go down or right. So oxygen here shares 1 pair here and 1 pair here, and there are 2 lone pair children. Water has 2 lone pair, means they are not shared. This is not shared. Okay, because of energy consideration, you could have said it could have shared with 2 more hydrogen. This could have shared, okay, with 1 each with 4 more hydrogen. So that is not possible because of energy consideration. So there are 2 lone pair of electron. So this is how we show hydrogen, sorry, oxygen will be in the middle, hydrogen will be on the side. And most important thing children, oxygen has 2 lone pair. So this is children what is our water molecule. So if you draw water molecule children, oxygen, hydrogen, delta negative. See, oxygen is 3.5, hydrogen is 2.1. Okay, so oxygen will attract the shared pair more towards itself. We don't draw this arrow, will signify coordinate bond. So try avoid using arrow, I'll tell you in my next video. So shared pair of electron is more towards oxygen because it is more electronegative. So later on you will see hydrogen bonding comes because this positive charge will now be attracted to another negative charge of this oxygen. Okay, so this is something like hydrogen bond. This is hydrogen bond. So this positive charge of hydrogen is attracted towards, I was telling you, opposite poles attract. So it attracts the negative charge. So this will attract another hydrogen. This is attracted by oxygen. So hydrogen bond is developed like this, that you will see later on. So children, this is what is once more polar molecule. Here we have hydrogen and oxygen, but we see oxygen is more electronegative than hydrogen. So it attracts the shared pair more towards itself. So it develops a delta negative charge, and hydrogen thereby develops a positive charge, and hence it is an example of polar covalent bond. So this is all, children, about polar covalent bond. In the next video we will see coordinate bond, where from ammonia we will go to ammonium ion, and from water we will go to hydronium ion and hydroxyl ion. Okay, so thank you, children, for watching this video lesson. Kindly pause the video and copy